the Kohler transfer switch is a service disconnect switch. So if somebody was to flip this to disconnect, this is going to totally shut the system down. It's going to put itself in a neutral where no utility and no generator, and then have to be manually reset. Basically, just if you need to. This is the Impact 1500 controller. This is basically the brains of the operation. It's constantly monitoring utility voltage. If the voltage falls outside of parameters, loses a phase, it's going to send a signal to the generator to start. Once it sees the generator is up and running and its parameters are correct, then it will switch over. Of course, this is all happening in under 10 seconds. By the time generator comes up, it gets running. You have these LED lights here. This one little dot on the top indicates what source is available. Of course, if we go out and crank up the generator, the E side would be lit up red, and then the other indicator indicates which position the switch is in, whether it's in normal, utility, or emergency. The LED from it, you can see right off the bat, it's scheduled to exercise, do its weekly test with no load. That's what NL stands for, no load. So basically all it's going to do is run the generator. It's not going to transfer. The first, so that's Monday at 7 a.m. is currently when it is scheduled. You can also see that it's showing normal voltage is 490 volts and 0 from emergency, of course, because it's not running. This also, don't worry about, you can play with these buttons without the password. You can't make any changes or do anything. Even to do a test, you need the password. You have 30 seconds to enter the password. If you don't, it just says incorrect password. It's not going to lock it out or anything. It's a default password. Let's see if the book should be in here. Here's your book, instruction manual for setting everything. Of course, you normally don't want to be in there, especially with it being hot. Basically, one gentleman had asked the sequence of operation. Like I said before, it's constantly monitoring utility voltage. As soon as it falls outside those parameters, the generator is going to start. It's going to see the generator, and it's going to transfer over. Now it's constantly monitoring, waiting, looking for utility to come back. Once it comes back, let's see what it's set at. Power outage. This is going to wait 3 seconds before it actually initiates the generator to start. If it doesn't see the generator in 1 minute, it's going to fault and shut the system down. Basically, as soon as it sees the generator, it's going over. Cool down. It's going to run for 5 minutes.
So what's the trip point? If it's monitoring the line voltage at 490 volts, what is the program to come on at?
It would be, let me see what they had. Sorry about that. Pickup is 90% and dropout is 99%. It's done off of percentages. Under voltage, 90, 90.
So that'd be 90% of 490.
480.
480.
Based off of 480.
Okay.
Yeah. And then it's going to.
Basically, it'd be about 440. Yeah.
And then, like I said, once it's waiting for utility to come back. Once it sees utility back, a timer kicks in for an additional 15 minutes that it's going to stay on to make sure that utility power is stable. Again, Florida, power flips on and off. If power goes back out, it resets that timer. Once that 15 minutes is up, then it will transfer back. Generator's going to run for an additional 5 minutes and then shut itself down and be ready to go. During any of this, if power or something changes, it automatically resets the timers. If it's during the exercise goes away. If it's still monitoring. If power goes out, it's just going to flip over and the exercise is done for that week.